Of these forms of linear equation, if you look at your formula sheet, that Ma10 formula sheet, you see one that says ax plus by plus c equals 0. The difference here between this and what you already know, the one you already know has the y all by itself on one side and the other stuff's on the other side. mx plus b. Slope-intercept has that y isolated, whereas this has all the terms on one side with a 0 on the other side. Sometimes when you write an equation, you end up with it this way. Sometimes when you write an equation, you end up with this way. It just depends on what information you're given. If you're given something about the rate of change in a situation, you're going to have the slope and you're likely going to do that. And if you get the starting value, you have the y-intercept, you're going to do that. Sometimes an equation or a situation means that it's easier to write it in that way. Okay, if we can have a look at a few of these things before you start doing some applied problems, just working with the form. Okay, general form, that form. I give you a little hint over here if you haven't done this already. How can you clear the fraction? General form, basically, if you want a definition of it, I didn't write it on here anywhere, but general form is everything on one side, no fractions. Okay? All terms, maybe this might be, it might help to have this written at the top of that page. All terms on one side. Okay, with no fractions. It's best if you clear out the fractions if there are any. Or decimals. Where that a, b, and c are different integers, right? So the first thing they ask you to do here is change this thing that's in. What form is that in? Yeah, so change from slope-intercept to general, right? From slope-intercept to general. It's not that hard, really. All it is going to mean is you need everything on one side and no fractions, right? So remember, all on one side, all on one side, and no fractions. Which one of those things do you want to do first? You want to get rid of the fractions first? You could do it either way. It doesn't matter which way you do it. You could put all the terms on one side first if you want, or you can clear out the fractions. If you notice that there's a single fraction, that's all there is, a single fraction, and it's got a 3 in the denominator, what could I do to get rid of that divided by 3? Remember, this part of this fraction means divided by 3. How could I get rid of that operation, dividing by 3? What's the opposite? Times by 3. If you want, you can show this and just say times 3. If I multiply that side by 3, what do I have to do to the other side? Yeah, you got to do that as well, right? I don't know why I'd put brackets there. I should just put a 3 there. What are you going to have then? 3y equals... Yeah, like if I'm doing 2 over 3 times x times 3, you can think about it over here. Here's you thinking. You don't look very happy, actually. And one eye is bigger than the other. But you're thinking of 2 over 3 x times 3. What do these two 3's do to each other? Cancel out. What do you have left? Your thoughts have to be expanded here a little bit. 2x. And then you become happy because, number one, you figured out the answer. Now you look just really weird, but that's okay. You've figured out that it's just 2x. Number one, you're happy for 2 reasons. You figured out the answer, and number 2, the fractions are gone. The thing that people forget is this part of it. The most common wrong answer there would be to leave that alone. What should it be here? What should be here? It's got to be 18 there, right? Because everything, each term has to be multiplied. That wasn't so hard, was it? So we did this, right? No fractions. Now what's the only other thing I have to do? Put everything on one side. Which side's the better side to move it to? Well, it's probably going to be, the best thing to do is make the leading term, which is the x. The x term's first. Move it to the side so that the x term is positive. So that means, which way are the terms going? To the right. This one's going to go over here. right? And you're just going to have 2x. Then I'm going to put the 3y, which is minus. Why does it become minus? When you move it from side to side, if it's positive here, it becomes negative on the other side. Okay, was that hard? It was not that hard. It doesn't, I mean, you can write it the other way now. You can say 2x minus 3y plus 18 equals 0. It doesn't matter whether it's left or right. Are we good? Sometime later on you can do this. Okay, try that one for yourself, not right now. When you're working through these, incidentally, I'm not sure that everybody's actually reading the title. It helps you understand what it is you're going to learn in that example and gives you hints about what to do. And I'm not sure that everybody's doing this, which is have a look in the textbook. That's the point of this, right? If you're trying the examples and you're not sure, look at the textbook to figure out what's going on. Here is something that is in what form is that called again? General form. That's general form. What you're asked here for are the two intercepts, X-intercept, y-intercept. If you were to have a graphing calculator, what would be your options for finding out the intercepts? Right now, as of this point, how would we have to go about finding the intercepts if you had one of these in front of you? What would you have to do? Can I put this equation in that form where it says y equals here, where you enter the equations? Can I put it in this form? No, you can't. If you're going to put it on the calculator, you need to make it y equals. And even if you did make it y equals, you're going to have the y-intercept at the end. You could do that. It's a lot easier to just leave it in general form and work out the intercepts by doing something that makes a lot of sense here when you think about it. Pretend you had the graph of this line. I don't know what it looks like, whether it's going up or down. It probably doesn't look like this. But I'm just saying because I want to draw. There's the y-intercept. There's the x-intercept for some random function, not necessarily this one. What is true about, what do you know has to be true at the y-intercept? If you had the coordinates of the point, x, y, one of them is 0. Which one is 0 at the y-intercept? X is 0 at the y-intercept. What's true at the x-intercept? Which one of them is 0? At the x-intercept, y is going to be 0, right? You can use that fact to figure this out, right? Okay. Here you want to find the, I should highlight this to coordinate it here, right? If we want to find the x-intercept, what are we going to sub in here? If you're going to figure out the x-intercept, sub in not x equals 0, but y equals 0. If you want to find the y-intercept, what are we going to do? Sub in what? X equals 0. You know what I mean by sub in. What word is that short for? Sub. Substitute. Okay? I mean, it could be short for a few things, but substitute in this case. Do you want to watch how hard it is to substitute in the number here? It's very hard. You put 2x minus 3y. Whoops. If you want to, you can put the 6 on the other side, but for now, let's leave it on this side. You'll see why you might want to start to put it on the other side sometimes. Then it has a different name, but if I was to substitute this in here, you're going to be able to substitute it in your head. That's why it's going to be pretty easy here. I'm putting in y equals 0. So in this spot right here, I'm going to put a 0. I'm going to put it in red just so we don't lose it. Put brackets around it. Minus 6 equals 0. What happens to this whole term if that is 0? What happens to that whole term? That whole thing becomes 0. 2x minus 0 minus 6 equals 0. Do I even need to write minus 0? No, just write 2x minus 6 equals 0. That's a pretty easy equation to solve, isn't it? How would you solve that? Or how do you solve that? You might just be able to see what it is, but you could put the 6 on the other side and just say 2x equals 6. What does x have to be? 3. X is 3. What that tells you about the graph is x is 3. There's the x-intercept, that point right there. Right? You know the x-intercept has to be that point. If you do a similar thing for the y-intercept, you could change it to the other form and see what it is, but you could also just substitute it in here. 2x minus 3y minus 6 equals 0. Which one was I substituting? If I want the y-intercept, I do the opposite one. X equals 0, right? So I put a 0 there, and then work the whole thing out. 2 times that. This whole thing just disappears. I'm just left with negative 3 minus 6 equals 0. Or in other words, how can I solve that? Well, you could do either way. I like to move the y term over to make it positive 3y equals negative 6. Or you could do it the other way. It doesn't matter. But whatever you do here, what does y have to be? Y has to be negative 2. Don't get the thing wrong because you solved this equation wrong. Check it out after to see if it makes sense. Y is negative 2. It means that on the axis right there, that's the y-intercept. Basically what you could do is, you can do this in your head more or less quickly if you do this, okay? This is you in your head here. Again, we have to draw you again. Try and draw you a bit better. You're happy because you know a bit more now. Okay? These are the thoughts that are happening in your head. Well, I'm pretty sure it's not actually the thoughts that are happening right now, but your first thought might be, if I'm solving for one of these variables, I actually would rather have the 6 on the other side. So in your head, you're saying, what if I was to move the 6 to the other side? Here I go, moving the 6 in my head over to the other side, except for when I move it, what do I have to do? Make it positive. So you did that in your head first because it'll help. And then you don't like to have your thoughts untidy, so you move this over closer, right? Move the equal sign over closer. And you move the 6 over because you like to have tidy thoughts. Here's what I mean by it's really easy to do if you're thinking about it here. Let's just make a kind of a blue splotch here of some sort to cover stuff up. Not that. Oh my goodness, that was strange. We need this to be a bit bigger here. Okay. Actually, you know what it should be? It should be white. I'm going to write with the white pen here. Okay, watch this. If you're finding the x-intercept, see this box I'm moving around, even though it's white, you can't see it. You can see it because I have it and it's blue right now. When we were finding the x-intercept, which thing do we make 0? Okay, you made the y into 0, right? Which means this whole term's going to disappear. Do you want to watch this magic, see it disappear? Except we need a bigger splotch. So we need to write with the white pen a little more. Here's the thing, okay? Watch this. Cover this whole thing up. Oh, it's terrible. See, when you try to see that, see how it covers it up? What does it say now when you cover that up? What does it say? Cover this up. It says 2x equals 6. What does x have to be? 3. What about if you're finding the other one? Which one do I cover up? 2x. What does that say? Negative 3y equals 6. You basically can just do it by covering up one of the terms. If the number's on the other side, you can say, I want the x-intercept, cover that up. 2x is 6. I want the y-intercept, cover that up. As long as you move that number to the other side, it's really easy to do. If you're given a number in general form, if you're given an equation in general form, the simplest way to do it is do it with the intercepts. If I'm trying to draw this graph, is it enough to just have 2 points to be able to draw the graph? Oops. Are 2 points enough to draw a graph if it's a straight line? If it's a straight line, it's enough. If it's not a straight line, it's not enough, right? Here's a ruler, because I wouldn't want to draw a line without a ruler and show bad habits to you. I know you can't see it on the screen. I'm holding an actual ruler. You see it? And I'm going to use it to draw my line. I want to teach you something that is probably common sense for a lot of you, but maybe not in this situation. Here's the common sense aspect of it. If I was trying to locate a straight line, like if I was hiring someone and I said, I need you to draw a straight line from here, like along this thing, and I said, draw a straight line, here's 2 points on the line. Or if I said, here's 2 points on the line, which situation is going to result in the line being more where I want it to be? Always. If I put 2 points really close together, or put 2 points far apart, which one has more potential for the person getting the line wrong? If I put them close, look how far apart I can make. Like, does this line look like it's sort of through those 2 points? Sort of. Well, but it's hard to tell if it's sloping, right? You can tell because you think I drew them horizontal. Let's put them like this. Does this look like it's right? Sort of like this, except I drew it too low. Try again. Does that look like it's right? Does this look like it's right? Maybe. When the points are close together, you're going to have more potential for mistakes. If I use what I'm saying here is if I use these 2 points on the screen, some people might do this and say, there's my line, I got it, right? Yeah, it's through the 2 points. Whereas somebody else might say, yeah, I got it here. It's through the 2 points this way. But you'd be wrong, possibly, right? If I have these 2 points, if this one goes over 3 and up 2, you should use the slope as well to just say, where should the next point it goes through be? If it goes over 3 and up 2, just keep going with that pattern. Over 3, up 2, it should be there. Over 3, up 2, it should be right here. It's going to miss, right? Over 3, you can follow the pattern here, and I'm kind of missing, right? The line is in the wrong place. If you're going to draw the line, follow the pattern over and put a dot there. Over 3, up 2. Follow it this way. Over 3, go backwards. And then just use the far points, right? Use this one and this one to draw the line, because it's going to be more accurate that way. Okay, using the ruler again so that I can actually show you what you're supposed to do, even though you can't see it on the screen. Using a ruler. That line is going to be way more in the right place because I used points that are farther apart. Okay? Okay, last thing here. Here was the things we need to look at. We have looked at 2 of the things. We have looked at general form converting. Okay, this is checked off the list. We have looked at thing number 2, which is sketching a graph using intercepts. We just did that. Find the 2 intercepts and graph it. And now what's the third thing we need to look at? Yeah, you need to look at this horizontal and vertical lines. Horizontal and vertical lines. Well, what do you know? The third example deals with horizontal and vertical lines. Horizontal and vertical lines are slightly different here. Let's just pretend, so I'm going to use actually something not on this page here. I'm going to use actual just plain paper here. If you want to copy something down, you can. You know, like in the olden days when you had to copy down everything and you didn't have fancy handouts where 90% of it's written for you already. Let's pretend you just had some axes like this. Let me just draw some lines here. And so let's say, now we're looking at horizontal and vertical lines. What color would you like one of the lines to be? Green. We actually can go a little further. We can go to these colors here, you see, like plum. How about if one of them's plum? Plum, you want a plum line? Plum, actually, interestingly enough, when you say you have a line that's vertical, like if you're a carpenter or something like that, you say this line has to be, or this board has to be plum, it means this. Okay, plum. Plum means exactly vertical. What do you call it when it has to be exactly the other way? Now there's not going to be a color this name, but I'll make it sea green because the sea is nice and the surface of the sea is nice and on a calm day it's nice and smooth and something that's perfectly horizontal is called what? Starts with L. It's actually the same forwards and backwards of the word. No, it has 5 letters. It's LE to start with. So, and it's the same forwards and backwards, which means those were, that's level, okay? This line here, this line here, this line is level on that grid. This line is, this other line here, I don't have to keep changing these crazy colors. This is plumb, okay? Chartreuse. Those 2 words, it's worth knowing, plumb and level. I didn't mean to get you all excited about that, but let's start with the easier one, which is the level line here, this line. Okay? This line right here. If I asked you, you could tell me what the slope of that line is, right? What do you think the slope of that line is?
0.
The slope is 0, right? What is the y-intercept of that line? Does it have a y-intercept? What is it? It has a y-intercept, right? What is the y-intercept of that line? The y-intercept is -2, right? It crosses the axis right there at -2. It has a slope of 0. Even if you didn't know how to write the equation of a horizontal line, you'd still probably get it right because you'd write it based on that. If you know these 2 things, which form can you use to write the equation? Which form can you use? Slope-intercept. So you can write y equals mx plus b. You can fill in the 2 things that you need. You need slope and you need y-intercept. So you're going to put in here, what are you going to put? Y equals, what goes in there for the slope? 0. Plus -2, except for what's the simplest way to write plus -2? Just -2. What's the simplest way to write this equation? Because you can write 0x minus 2, but you don't need to. What's the simpler way to write it? Y equals -2. That's the equation of the line. It couldn't get any simpler than that. Okay? Y equals -2. The problem is for grade 10 students when they first learn this is this doesn't look like an equation to them for a line. Because they are so good at learning that lines should look like that or like general form that when it's as simple as just y equals -2, they get confused and say, well, that's not an equation, it's just a number. It just says y equals a number. Let me draw for you an amazing red dot that is going to be 2, whatever those are, wide. 2, it's not pixels, but it's whatever. Okay, the amazing red dot is going to be an extra large point that is on this, that's not going to work. An extra large, see, when you try to do something amazing, it just doesn't work. This is not such an amazing dot, I'll tell you that much. You know what? Oh, come on. Okay, we need another amazing. This is an actual amazing dot, I think. And if it's not, I'm going to go back to the drawing board. There we go. That's this dot is not amazing at all. This one is amazing. Watch how this dot moves along this line. Okay? See this? See this? Isn't that amazing? The amazing thing is, it's not really amazing, but what would the coordinates be here? That would be -2, -2. I happen to pick one. That would be -2, -2 there, right? Now, I'm telling you about amazing things, and I should just actually do something actually amazing instead of trying to convince you that a red dot is amazing, because it's not really. This will be better. Dynamic mathematics for everyone. This is actually a graphing program. If you ever need to graph something for whatever reason, it's free. It's called Geogebra. It's free to use. You can run it. You can run it from my website, or you can just Google it and find it. Let me draw for you the line here. What was the equation of the line again? What did we say? It was pretty simple. Y equals what?
-2.
Y equals -2. Do you see how there's a line there at -2? And we probably don't have plum here, but we're going to go and try and change the color so it matches somewhat. We will make it thicker so you can see it. We will make it more or less in some kind of neighborhood of plum, even though that's probably not plum, it's purple. I will put an amazing dot on here for you, except it's not red. And you can see what the coordinates are. We will make it slightly bigger. We will make it red. And we will do something where we don't care about the name of that point, but we care about the coordinates. Here's the amazing part. Watch carefully what happens when I move this point. What happens? What is happening to the coordinates there? The x is changing, the y is staying the same. Why do you think the equation of that line is y equals negative 2 instead of x equals negative 2? Why is it? More than half the people in grade 10 get this wrong. They think the equation of this line, it should be x equals negative 2. And the unfortunate thing is, even though they learned a lot in Math 10 about this, they get to the provincial exam and it says, what's the equation of that line? And the choices are y equals negative 2, x equals negative 2, and then two other things. And too many people pick the wrong one, which is x equals negative 2, because in their mind, this is what I think I finally figured out what they're thinking. They're thinking horizontal line, sideways line, and their grade 8 teacher or grade 7 teacher drilled into their head. The horizontal axis here is called what? The x-axis. So they think horizontal must be x equals. Doesn't work like that. The line's horizontal, but what coordinate is changing? X is changing. What one isn't changing? Y. The equation is y equals negative 2 because it's saying no matter where you are on the line, y is equal to negative 2. Here's the big test then in your powers of logic, not your powers of what I've taught you already. What if I put in x equals? Now don't say it right away. Just think about it and let everybody think about it. What if I put in x equals 3? What if I put in x equals 3? What's it going to look like? Somebody want to tell me? Everybody's thought about it, right? What do you think it's going to look like if it says x equals 3? What's it going to be? Vertical line. X equals is a vertical line. You can't see it very well because it's thin and it's not a decent color. And I know you will be able to see it much better when we make it. I even made the color wrong last time, didn't I? That's why you're confused. I understand now, because it was supposed to be sea green. And this one was supposed to be plum. It's so confusing. Okay, while we're at it, let's put a label on that. And let's put a label on this, which is going to be what it's called. Okay? You notice how this one says y equals negative 2. This one says x equals 3. If I do the thing with the point again here, there's a point. Okay, there's a point on that line. We're going to change it so we see the value. We're going to change it so you happen to see that it's bigger. And we're going to make it a completely random color like disgusting yellow, which is actually disgusting green. Well, it's like dark yellow, which ends up being weird. Okay, watch this point as I move this. Now you're thinking about disgusting yellow. What's happening as I move this point?
The y is changing.
Y is changing. What is not changing? X is not changing. This is why the equation of that is x equals 3. Alright. Last thing here. This example is a piece of cake now that you understand it. In the past, if I just told people, I think you got to go from an understanding point of view. What about this if I ask you to graph that? You might get confused because it's like, well, as soon as you look at it, you should look at it and say, so if this is your thoughts, right? If this is your thoughts, carefully, okay, listen. Listening quick would be better. You have enough to be able to do this one. Write it like this, it's obvious what it is then, right? Move the term over, if you look at the equation only has one variable in it, It's got to be either horizontal or vertical. If it only has an X in it, that's a vertical line. If it only has a Y in it, whether it says Y equals a number or it says like that, it's a horizontal line. When you come back from lunch, you're going to work through this, and we need to get this section completely done today. Okay? Examples, show your nose, homework. Okay? See ya.